Hi, good morning. Hi, how are you? Come on in, have a seat, relax, take a load off. Okay, first things first. Light mode or dark mode? Dark? Okay, light? Oh, that is not conclusive at all. Whew. Okay, well, I think I saw ever so slightly more people favoring dark mode, so I'll leave it as is. Good morning, good afternoon. Hi, everybody. I'm good. Just so happy to talk to you all. Welcome, welcome, welcome. Come on in. My name is Josh. I work on the Spring team. I'm so happy to be here with you all today. Before we get too far away, just letting people trickle in. I just want that to happen whenever they can. My name is Josh Long. Like I said, I'm on the Spring team as a Kotlin Google developer expert, a Java champion, and most embarrassingly, and look, we all do things we're not proud of, but most embarrassingly, I am a YouTuber. So you can find me on there. I'm not proud, but it's a thing we do to connect, right? So you can find me there. This is a little channel, and it's actually not my channel specifically anymore, right? I've actually added my buddy Deshaun Carter. He's awesome, and just yesterday we announced the one, the only, the amazing, the inimitable James Ward will be joining the channel. So now we have 3 contributors on a regular basis, and I'll tell you, it's gotten better thanks to those two. But when it was just me, it was well, I wouldn't have told you it was great. It was anything. But anyway, join me there. It's fun. Like and subscribe, that kind of thing. Look, friends, I'm really excited to be here with you all today. I wanted to talk about this latest and greatest in the Spring ecosystem, as always. But before we get too far underway, what I wanted to do was to take a quick selfie, okay? Let's just do one quick selfie. Pretend like you're happy. Just pretend, okay? Just ready, steady, open source. There we go. Thank you. Thank you, thank you, thank you. As always, for those of you wondering what I'm going to do with that photo, I'm going to show it to my daughter. I'm going to say, see, they listen to me. Okay. Look, my friends, as always, I'm just really keen on having a good demo, and I thought we could maybe look at the old Spring Pet Clinic or something like that, but I thought that's a little too much, a lot of too many moving parts, but I do like the idea of animals and dogs and cats and that kind of thing, so I thought we might revisit that theme and talk about animals, and I love animals. I mean, I love almost all animals, right? Almost all animals, except my dog. He's the worst. He's the worst dog. He does not know how to dog. He never learned, and he's not a good dog. But he's ours, so we keep him and we love him. And that it gets me to the 3 reasons why we keep him. Right. The first and foremost of which is all dogs, no matter how terrible, deserve loving homes. Right. And so that's part 1. Part 2 is just ego. Okay, I'll just be real with you. In my home, my partner and my daughter both speak 5 languages, and I only 3.5. So if we didn't have that stupid dog, I would be the stupidest in the house. That will not stand, okay? That wouldn't stand. And then finally, just being real with you all here, just being absolutely honest with you all here today, he is pretty stinking cute, right? Like, pure cuteness on the outside. He's evil on the inside, just pure malice and malevolence on the inside, okay? So this is actually the best way to experience Peanut the dog, is through a photo on a different continent, right? He can't get you, probably, right? And so I think about this dog a lot because he's just terrible. But I also think about another dog that I learned about during the pandemic named Prancer. And this dog, there's this woman who put out an ad back in 2021 looking for a new home for this dog, and she describes this dog in great hysterical detail, and this ad went viral. She said, I've tried for the last several months to post this dog for adoption and make him sound palatable. The problem is he's just not. There's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins. But I have to believe there's someone out there for Prancer because I'm tired, and so is my family. Every day we live in the grips of the demonic Chihuahua hellscape he has created in our home. And so she continues, he was quiet and just laid on the couch, didn't bother anyone. I was excited to see him come out of his shell and become a real dog. I'm not convinced at this point that he's not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home. And she continues that Prancer wants to be your only child, which is rather ominous. And she signs off saying, oh, he's only 2 years old and will probably live to be 21 through pure spite. So take that into account if you're interested. So anyway, sounds like a spicy dog. I think about this dog a lot, right? And also super cute, right? Super cute. I'd pet that dog. Come on, look at him. He's adorable. And so this dog went viral, right? This dog went viral. Here's People Magazine. I don't know if you have People Magazine over here talking about this dog. And here's BuzzFeed talking about this dog. Oh, he's talking about this silly dog. And then what is this one? Oh, yeah, that's BuzzFeed. Oh, this is BuzzFeed. That one was USA Today, the newspaper. Here's the BuzzFeed talking about the dog. And here's the New York Times, right, talking about Prancer the demonic Chihuahua from that ad, right? And they're all just very concerned about this dog's upkeep and life and subsequent results. And so I think about both of these terrible, terrible dogs a lot, right? And I thought, well, what if we built a system to help adopt these dogs? So that's what we're going to do. And we're going to do that by, as always, going to my second favorite place on the internet, start.spring.io. Obviously, my first favorite place on the internet is production. You know, I love production. You should love production. You should go as early and often as possible. But if you haven't been there, you can begin your journey here at start.spring.io. Okay, so we're going to build a new service called Adoptions. We have some choices to make, namely which versions of Java to use. Look, friends, Java 25 comes out later this year, and that'll be Java 25 in the year 2025. So obviously, you should be on Java 24, getting ready for Java 25. Anything less than Java 24 at this point is just weird, right? People are laughing at you. They're snickering behind your back. Don't do this, right? Be the change you want to see in the world. Do the right thing. And remember, Java 24, mathematically, okay? Just let the math bear it out. But mathematically, it's 3 times greater than Java 8, right? That's a fact. That's a fact, okay? This is just science. So we're going to add some support here. We're going to build an application that uses the web server support. We're going to use GraalVM. We're going to use Spring Module because I want to structure my code base in a modular way so as to reduce the blast radius of change. And what I mean by that is to write my code in such a way that I don't inadvertently create dependencies upon which other parts of the organization, or indeed other people on the team, can accidentally depend. Okay? So Spring Module, Spring Web. We're going to bring in a database. I'm going to use a Spring Data JDBC. I'm going to use Postgres. I'm going to use a Spring Boot actuator, maybe. Yeah, sure, why not? I'll use DevTools. And you know, what else do I need? I think I want, you know, you can actually get a database if you use Docker Compose. You can actually just hit Docker Compose, and it'll generate the compose.yaml file for you. But as it happens, I happen to have up my sleeve a pre-configured database full of data, so I'm not going to bother recreating the Docker image there, but it's just nice to know that you've got that option, okay? So DevTools, Actuator, Postgres, Spring Data JDBC, Module, Web, GraalVM. Okay, I'm good with that. Let's go ahead and open that up in our database, okay? In our IDE, rather. Here we go. And the goal here, again, we're going to write our code in such a way to take advantage of Java, right? Java is a nice object-oriented language. I want to take advantage of that feature, of those features as much as possible. Can you read this font in the back, by the by? No? Okay, how about now? Who cannot? Anybody cannot? Just raise your hand if it's too small. Okay, good. Okay, so what we're going to do is we're going to build a public static void main application, obviously, talking to the data source, which I need to configure here, JDBC, Postgres, QL, and we'll say localhost my database. And, you know, obviously, we need to specify a username. Whoa, that was fun. My user. And a password is secret. Now, one of my favorite features in IntelliJ, you just click on that little button, hit test connection, click, go, apply, OK. Go over here, refresh, public, tables, et voila. There's our dog table. And there are the dogs, and there's our buddy Prancer. ID is 45, name is Prancer. He's described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like gremlins, okay? So our job is to adopt ID 45, okay? So we're going to build a system to do that. And obviously, we'll start with our package, and this is going to be our root module, okay? In there, we're going to have a dog adoption controller, okay? And in there, notice that IntelliJ puts this as public. Why? Why? It should not be public, right? In Java, classes are packaged private by default. Indeed, that's what they should be by default. You should be going out of your way to add public to the type, okay? So we're going to say class dog adoption service. Service, okay? Service, hello. And, you know, I'll make this a service, and I'm going to delegate to that. It's going to have a method here, void adopt int dog ID, string owner, right? And we're going to, in order for that to work, we're going to need to talk to the database. So I'll create a record, right? I'm going to use a record to map my domain to the SQL table that I have there. And you saw the SQL schema just a second ago. So I have an ID, a name, a description, and an owner. Okay, and then we have the dog repository. This is going to be using Spring Data JDBC. I love Spring Data JDBC. You can use whatever you like, but I love Data JDBC, and I love records. I just love records so much. Big fan, okay? Now, we're going to inject this dog repository there, add that to the constructor, and here I'll say this.repository By the way, did you see one of my other favorite features? Watch this. Dog repository. Isn't that nice? Okay, so find by ID, dog ID, if the dog is present, great. And I'm going to update it by writing it to the repository like so. So new dog, dog.id, name owner. Oh, that's so good. That's so good. You can't deny that the smart line completion that we have available to us nowadays is not useful. I mean, that is just so good. Okay, so updated. Or actually, I suppose the verb is not really updated. We didn't update Prancer so much as we've adopted him, right? Okay, so there we go. Updated. Voila. Okay. So let's try that out. I think that's already kind of useful. We need to create a simple endpoint here to test it out, I guess. So we'll say dogs, dog ID, and it'll be adoptions, yeah? So void adopt, and then it'll be a path variable and a request param. And this dot, what do we want? We want dog adoption service dot adopt, passing in the details there, yeah? Okay, so let's go ahead and start that up for the very first time. And remember, we're using it with dev tools as well, so it's going to start it in a separate isolated class loader, which means it can then throw away that class loader on every single class file change, okay? So dogs, 45, adoptions, okay? And it's a post, so I'll say dash dash form post, and the owner will be JLong. Yeah? All right. So if that's done its job, then we can go to this table now, and where it was null, it's now not, right? And if you can see, I can change it to just Josh. Refresh that, and now it says Josh. Okay, so it's fine. It's worked. That's not a very real application, though, right? Not a real example, but it's done the job. We've successfully updated that single column, the single table in the single database, but that's not typically how you would take possession of a live animal in most jurisdictions. There's going to be process involved, certainly. So you can imagine, for example, needing to schedule a checkup with a veterinarian before you can take possession of the animal, right? So I might have a package here called vet. And remember, a veterinarian is a doctor for dogs, so we shall call this a dog tour. Okay. Now, at service, and you can imagine public void checkup int dog ID, checking up on dog ID. Okay, and you can imagine how that might go. I might, for example, inject in my method here, my service. I can imagine injecting the checkup method and doing. I could do that. But the problem with this is that this unnecessarily complicates this code for no benefit. Remember, I need the thing that's happening in DogTour to happen, but I don't need it to happen in this code. I don't even depend on the results. So I always look for ways to disentangle these things, to disconnect them, to decouple them. One way we might do that is by using messaging. So instead of that, instead of creating a direct coupling and unnecessarily complicating that service, let's instead use event-driven architecture and messaging to do that. And I'll create my first intentionally public type, okay? Record int dog ID, and then that's it, right? That's my event, and it's public. And I'm going to now publish an event using Spring Framework's application event publisher, okay? And I can listen. And by the way, this event publisher has been in Spring Framework since like 2000, right? 2003, I mean. So we'll go back to the dog tour. This doesn't need to be public anymore, nor does that. And I can just make this an event listener that listens for that event. Much nicer. So go back to the controller. Where's our issue? Get rid of that. Voila. Okay, so now if everything's gone to plan, there we go. You can see it says adopted dog and now checking up on dog adoption event. So we've done it. We've got one side completely unawares of the other, right? They're decoupled in that sense. And we like that, but the problem is, are we truly decoupled? Well, if I went to the dog tour and I added some sleep, thread.sleep, okay, 5,000, which is 5 seconds, right? And then I go back here, and then I republish the request. 5-second wait. 5-second wait, right? I'm waiting. So they're not actually decoupled. One is existing in the same thread as the other. So there is a bit of a coupling. One way to get around that is to use application module listener. This is from Spring Modulith, right? So Spring Modulith lets me, get async execution, which I could do, by the way. I could use @async directly, but this gives me async execution, and it solves the biggest problem with async execution, which is that the code is no longer executing in the same thread, and therefore I lose transactionality, and therefore I have the risk of an inconsistent state. So I'm going to tell it to republish the outstanding events on restart, right? And I'll tell it to initialize the schema, whatever schema it needs, in order for it to do its work. One of the nice benefits, by the way, of using decoupling like this, using a messaging, is that things that don't need to be public, like our domain,
are not public, right? Remember, I've harped on this a lot, but it's very important to remember we don't want this class and other things that are not supposed to be public to be public. If you notice that we're putting everything in the adoptions package, right? So we got the domain, the service, the controller, all that in the adoptions package. This package is a feature, not the role. It's not a service package. It's not a controller's package. It's a feature package, right? This is, I think, a stark improvement over some of this sort of anti-patterns you see being cargo culted from things like Ruby and Rails, right? Don't do that, right? Like, remember, we're using Java. It's an object-oriented language. It has information hiding. If you want everything to be public in a flat global namespace, just use C, It's more honest. Do that. Don't use Java. You're not. This is an abuse of the language. Okay, so what was I doing? Oh, yeah. We publish. Great. Go back over here. Refresh the tables. What do we got? We got a new table there called event publication, and you can see the listener ID, the event type, the serialized representation of the state, the publication date, and the completion date. It's not finished yet. It's been 5 seconds, so presumably it can finish that. Well, whoops, did I do, yeah, that's fine. Oh, you know what I forgot to do over here in the dog tour? Forgot to make this also transactional so that it participates in the actual back-end transaction. So what we'll do is we're going to run the same exact thing one more time, publish, go over here again, and this time you can see it's null, but give it a second or so, 5 seconds in fact, and there you go, it's not null, right? So this gives us the ability to make sure that we didn't accidentally mishandle missed messages. This is very, very important. This is called the outbox pattern. We're using a transactional resource like a SQL table to reconcile non-transactional resources like our event dispatch or messaging or FTP services or Kafka or whatever, right? Very, very, very useful way to build scalable systems. So Spring Modular gives us the ability to build code that is decoupled. It scales well. We're using good object-oriented design while also keeping ourselves in the Rails, so to speak, right? This is actually, I think, if anything, the true Java on Rails approach. Now, how do I know if it's modular? What does modular mean? Well, I've got adoptions, and I've got vet. These are 2 root packages, and they've got types in them. And if I had a nested type, for example, a package here called validations, right? And I created another type in there called validation, right? Well, this is very clearly an implementation detail that I intend only to use from within the adoptions package. I don't expect to export this validation type to the vet package, right? It's a nested thing under adoptions. Good object-oriented precedence says I should keep this type here. So, for example, if I revisit my service and then I inject this, it'll be fine, right? But if I do that same thing over there in the vet package, it'll be a problem. And you can actually confirm as much. You know how? By writing tests. So we're going to go back to our test. We'll say var am application modules of, okay, and then we're going to use adoptions application.class am.verify. We can actually print out the modules like so. We can even document the modules like so, right? So voila. And let's run that test, okay? So now I'm using Spring Modular's awareness of this logical structure of the code base. Here's the modules, right? I've got the, it's green. Here's the modules, their dependencies, the logical name, the package name, the other module, etc. And the tests are green, that's good. And if you go to the output, you can see in the target directory that we have a Spring Modular docs folder, which has been nice enough to generate a plant UML diagram that shows us the C4 architecture component boundary of our system. Right? So now we can see logically how these things relate to each other. And if we should, for example, go a step further, go beyond the expected parameters of our design, we can, for example, inject validation over here in the other module. Well, let's run that same test now, okay? This is a leaked type. This is a nested type. It's public because of the Java language rules, but it's clearly not intended to be used in another root package or another root module. So that broke the build, right? So here we go. We got module vet depends on non-exposed type. DOGtour declares constructor validation, blah, blah, blah. So, it's telling me, hey, you can do this by the Java compiler, but you shouldn't do it by Java design, right? So if I restart that test one more time, here we go. Let's see. Good. OK, so we've got nice, clean, object-oriented code. Everything's green. I've got an HTTP endpoint. That's pretty trivial. Obviously, there's more under the sun than just HTTP. So let's go back to the start.spring.io. We've got this over here. I'm going to add some support for gRPC and for GraphQL. OK, so we'll copy and paste all that. Paste, and then Command-Shift-I, reload. So GraphQL, how many of you are using GraphQL? GraphQL. Okay, GraphQL is a protocol defined by Facebook, Meta, whatever. And we don't have the folder here, so source main resources GraphQL. Okay, and we'll create a file in here called adoptions.graphqls. And it's a nice way because it has all the things you need. GraphQLs, Josh, come on, you can do this. GraphQLs. Okay, it's a nice protocol because it gives you all the things you need to describe 3 verbs: queries, mutations, and subscriptions. Subscriptions are streaming responses. Queries are finite responses. And mutations are anything else. It's anything that updates the server-side state. So let's just create a very simple endpoint here that describes the dogs that come back from the system. And there's 3 different special verbs, like I said, and there's 3 special types that you describe in the schema. And so here's one for all the dogs, right? Notice that the name is on the left and the return type is on the right. You can actually have a parameter. You can actually say that this query, this attribute, this finder method, whatever, is named dogs, but it expects an ID. But in this case, it does not expect an ID. It's just going to return a collection of dogs. If I wanted a single dog, I'd do that, yeah? Okay, so I've got this. Let's go ahead and now implement that controller. So this is one of the things I love about GraphQL is that it's a schema first, right? You don't have to graft it on like we have to do with regular sort of REST and stuff, okay? So add controller, class, GraphQL controller. Okay, and again, we're going to keep this very simple, so I'll inject this service here. Okay, and then the service, does that have an endpoint called all? I don't know that it does. We can make it dog all. Turn this dot repository at find all, okay? So now we can use that from our controller over here. And we're going to create a query mapping endpoint, because remember, that's the name of the endpoint, right? So dog, all, and voila. Now I want to be able to, so notice that the IDE is telling me, hey, can't find the schema. Source main resources, GraphQL. Is it supposed to be GraphQLs? And what did I call it on the schema? I called it dogs. That could be why. So let's go over here and call it dogs. There we go. Much better. And I want to be able to test this stuff out, so I'll go over here to my properties, and I'll say graph ICL enabled is true, and I can reload the program itself. Go to the browser, localhost, graph ICL enabled. Okay, that was the original. You know what I did? I broke it by changing the folder a second ago. So we'll change it. GraphQL. There we go. So there's my GraphQL editor that I can use to interact with my GraphQL schema, and I can prove that everything's working just fine. This is nice because you get as much or as little of the data that you want. So if you want to create a lean view that only has the ID and the name, just specify as much in the query. And if you want more, then ask as much as well. Okay, so GraphQL, super useful. What about gRPC? Well, we have in the Spring ecosystem a new project called Spring gRPC. So I'm going to go here, Spring source main resources, and I've got source proto, right? If you go to the gRPC service, the configured service over here, you'll see that it will have generated in source Java proto resources. So source main Java source main proto. So proto, and then in there, I'll create a file called adoptions.proto. This is a Google protocol buff schema, and the syntax that I'm going to use is proto3, okay? I'm going to create a message. This is kind of like the types that we describe in GraphQL, and it'll be an int32 ID is 1. So I have to specify the offsets for the things that you're going to show in the payload, right? So string description equals 3, okay? And I'm going to create a service called adoptions, and it's going to have an RPC, request response style method that returns a collection of dogs. Well, now there's no array type or something like that. You have to create your own. So I'm going to say repeated dogs equals 1. Yeah, and the input type is void in effect, right? I have to actually specify that. You can't just like do parenthesis. So I'll say input Google protobuf empty. And now I can do Google protobuf empty. Okay, so that's my basic schema. But remember, this schema in this case is going to be transpiled into Java. So I have to specify a few things. I want this to be com example adoptions.adoptions, okay, .grpc. I want option Java multiple files is true, and I want option Java package. I've already got package option Java outer class name. Okay, equals adoptions grpc or adoptions proto. Okay, So with that all in place, I should be able to go to the build, because after all, if you look at the pom.xml here, I've got all this stuff that's been pre-configured for me. So I can go to the build now to do Maven skip tests, because I didn't write any tests. Package, here we go. And you can see it's generating the schema for that. And if you're using Visual Studio Code, who's using Visual Studio Code, by the way? Anybody? It's pretty good too, right? I'm not complaining. I'm just wondering. No judgment, no judgment. If you're using Visual Studio Code or Eclipse, who are using Eclipse? Okay, well, so IntelliJ. Yeah. Oh, okay. That's okay. Well, we all got the slightly shorter end of the stick here because if you look at the generated sources folder, you get this folder called protobuf. You need to explicitly mark that directory as a source root. For Visual Studio Code and Eclipse, that'll just get done automatically, I'm told. Now, with that done, we can go to our code, wherever it is. Here it is, HTTP controller, and we can implement now a service extending the generated code that was given to us. Okay, so grp service. And it's got to extend the type that was given to us. So extends adoptions, grc, okay. And we're going to extend that method, right? And I'm going to use the dog adoption service that we have already to get all the records. And we have to map it. We have to, in effect, visit each of the dogs that comes back from our SQL database and then turn it into the gRPC generated transpiled type there in the gRPC package, like that, okay? So .build. Build, and then .toList. So that's my updated code. So var transformed, let's say. Okay. And let's actually do that work here. So we're going to say set name is equal to rdog.name, set ID is equal to rdog.id, and of course set description is equal to rdog.description. Okay. So that's the transpiled code. And now we're going to return a response by observing that like that. Okay. And then finally we signal that we are done by saying on completed. So that's it. That's how you create a gRPC service. Let's go ahead and restart it and then take advantage of that as well. So we can use a nice command line tool called grpc curl, plain text, pointing it to localhost 8080 /adoptions/all, and there's our gRPC endpoint. So we've got a modular, well-designed code base that we can actually take to production. Obviously, we want to focus on that. Let me make this use virtual threads so you can non-blocking I/O for free. And then we're going to compile it into a native image. Now, the only problem is that GraalVM native images take a little while, right? And for years and years and years, I have been complaining about how long it just takes to do these GraalVM native images. Last December, our buddy Richard Fitchner put together a plugin in the honor of this long-standing GitHub issue I have on the GraalVM native image project that fixes the issue. It's a Maven plugin. So what I'm going to do is I'm going to use that Maven plugin like so. So where's the simplest configuration? Copy and paste that. We'll go back to the build, pom.xml, down there, okay, plugin, get rid of that, and then this is 1.0. Yeah, there you go, 1.0. Now we're going to compile a native image, okay? And what that does is well, you'll see. So skip tests, -p native :compile. Ah, so good. I've been asking for this for years. Like, I asked in the GitHub issues, right? This has been a long bother for me, and I've been asking for years and years. I went to the GraalVM project at Oracle, and I said, please play elevator music during the native image compilation process. That was 2022. And I already hear elevator music in my head when I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance. Somebody said you can make it this elevator music. Somebody else said that adding beeps is good, like a microwave. That makes sense, right? This guy, our friend Dr. Fabio Niephaus on the GraalVM team, says, thanks for your request, but it would only fix the symptoms, and he suggested he's working on a Josh Long mode. And that Josh Long mode has never been implemented, but I can imagine it would be amazing, okay? Oh, Europe, let's see. There, so you click on that, and that would be that you run the native image compiler, that's that, and it would print out music brought to you by Josh Long, and then show, well, Josh Long, right? That's me, right? So here we go. Like, that's what I'm imagining should have been merged into the compiler years ago. Hasn't been done yet. So thank you, Richard, for fixing this long-standing problem. Okay, so I think our code is done. Let's go back to this, cd, this, adoptions, target, adoptions. What happened? Oh, you know what it is? You got to be very careful around this. You got to be very careful because you've got the observability stuff, which I didn't actually end up using. We don't have time for that. We'll move on. In Spring Modular, some of which at runtime uses the test code, which is weird. So never mind. Get rid of that for a moment. Oh, that's so sad. I have to do that whole thing again. Oh, that's so sad. Okay, so we'll do minus d skip tests minus p native colon compile, and we'll let that do its thing in the background. Okay. And then in the meantime, by the way, you can do the Maven daemon, right? Don't do that with this because it continues to play forever, right? The Maven daemon just keeps the daemon running all the time, so it's not exactly what you want. You can't get it to stop. In the meantime, I think we need to build an assistant to help people find the dog of their nightmares, right? So let's do that. We're going to build an AI-powered assistant using Spring AI, which, by the way, goes GA on the 20th of May, right? So like 11 days from now. Okay, so we're going to build an assistant. We're going to use the PG vector. We'll use the web support. We're going to use the GraalVM native image support. We're going to use, I don't know, I think that's it. OpenAI, Spring AI, GraalVM, that's probably fine. Hit enter. And we'll go to the downloads directory. UAO assistant.zip. Okay, assistant. Okay, it's done. Let's see if that worked. I love that it's like a, it is perfect elevator music. Okay, here we go. Take 5. Oh, port in use. Okay, that one we can fix. Over here. Go over here. There we go. That's our native GraalVM image running in 0.12 seconds that contains everything we just built. And more importantly, if you look at the RAM, the resident set size measured in kilobytes, so divide by 1,000 to get megabytes, it's about 123 megs of RAM to run that process in production, right? That's a huge improvement, and you get it for free just by using GraalVM. So, okay, back to this. This is our assistant. We're going to build a simple HTTP controller that answers questions about the dogs in the database, right? And so this is sort of like when you go to the shelter and you want to talk to the people that run the shelter, you want to have somebody answer your questions about the dogs and their past and all that. So we can have an AI-powered assistant to help with that effort, okay? Dogs, and then we'll have a user context, and we'll have a method here called inquire. And we'll have the path variable, the string username, and then we'll have the request param, which is actually the question being asked by the would-be dog owner. Okay. In order to answer those questions, we're going to use Spring AI's chat client. Now, I love the chat client, right? This chat client is a huge deal. I'm a big fan of all the people that worked on it. I believe it's going to be really great code, huge, really well done, really, really well done. Okay. And we're going to say this.ai dot prompt dot advisors dot call dot content dot there you go, that's it. So we don't need the advisors. And then the user prompt we're going to pass in here, okay? So there's the question, and we'll get back to what this user is doing for us in a bit. But we've got this chat client. We have to build it by injecting the builder. Can you imagine? So there we go. And let's just try running this on port 8081, huh? So port 8081. Now, I love the AI stuff that we're looking at today. Spring AI is an amazing project it's your one-stop shop for all your sort of AI engineering needs. Remember, we are in a uniquely amazing position as Java developers and Spring developers because while you can prototype the dickens out of your average AI thing in Python and you can train your models in Python, most of the work of integrating and leveraging AI today is about integration. Remember, most of these models are just REST endpoints. Okay, that's our bread and butter. And where is the business logic and the data that these models need to do their interesting things? That's all in Spring and in Java. So we are able to better benefit from all that. We are in a uniquely great position to take advantage of that. Okay, so let's go ahead and start that. Okay, let's just try it out. Let's just see if we're on the same page. So 8081, what did I call it? I called it dogs, and I'll give it a username, Josh, inquire, question, equals, my name is Josh. Okay? Okay, not allowed. Why? Oh, post. Well, I'll keep it simple. Okay, whatever. I don't care. Okay, my name is Josh. Yes, nice to meet you, Josh. Haha, we're friends. I love that. Let's see, what's my name? Why can't I have friends? It says, I'm sorry, but I don't have access to personal information. It's already forgotten me. You know, I have that effect on people. But okay, fine. So the AI models by themselves, behind the scenes, don't keep track of what you've sent, right? If you talk to ChatGPT or Gemini in the browser or whatever, those things keep memory, but by default they don't. So we need to actually set up our code to take advantage of that. And actually, I wanted to do something I need to move to snapshots. That's what I want to do here, because remember, GA comes out in just a hot minute. So we're going to move our code to the snapshots. I'm going to add a dependency to the dependency management section here. And we're going to move Spring AI 1.0 to snapshots. Where's my Spring AI? This is M8. That's creakingly old code, okay? That came out last week. I won't be using that today. I wouldn't do that to you, okay? So we've got that code. So we need to give this thing memory, and there's lots of different ways to do it, but we're going to configure that as an advisor. So we'll have a map here, private final map string prompt chat memory advisor memory memory new concurrent hash map whatever. What are words? Here we go. So that's a map of user to memory, okay? And we'll say this dot memory dot compute if absent the username, and then we'll say given that compute a prompt chat memory advisor. And advisor is like a filter that pre-processes and post-processes requests intended for the model, okay? And so we're going to add that. And then what do we put here? Well, I want to put a memory. I want to put a chat window memory, okay? Here, it's a chat memory implementation. So chat memory implementation. We want one of these things right here, message window chat memory, okay? There we go. This one, dot builder, dot chat memory repository, dot build. Now, where do we get the chat memory repository? We're going to use the in-memory one, but there are ones for SQL, and I think there's one for Neo4j, and one being worked on for Redis, and you can imagine, right? Everything. So in-memory, chat memory repository, and then we'll put that over here, yeah? There you go. So there's memory. And basically, we're going to compute this filter, this advisor, if and only if the user doesn't already have one. Otherwise, we'll just pass back the existing one, because that's the whole point. We want stateful transcripts of the existing discussion, right? Because they're going to forget otherwise. These models need to be reminded on every subsequent request that something has changed. Okay. Okay, so we go here. And now, what's my name? Oh, it's not going to know now. We have to tell it, right? My name is Josh. And then, what's my name? Hey, it knows. We're on the same page. Good. Now, it's still not answering. Like if I ask it, what's 4 plus 4? I don't want people using our dog shelter to help people do their homework, right? So, like, it's going to tell us 8 equals 8. It's just a direct pipeline to the model. So we need to steer its actions a little bit by giving it a system prompt. I happen to have a system prompt that I've pre-written. Let me just cat this to the buffer here, to the pasteboard, and I'll no, that's wrong. Sorry, it's there. I'm going to dog it to the buffer and paste that here, okay? And we'll say var system equals, and this is a system prompt. This governs its overall tone and tenor, okay? And it says you are an AI-powered assistant to help people adopt dogs from the adoption agency named Pooch Palace, with locations in Antwerp, Seoul, Tokyo, London, Singapore, Barcelona, New Delhi, San Francisco, etc. Information about the dogs will be presented below. If there's no information, return a polite response suggesting we don't have any dogs available. Fine. So now if we try it again, what's 4 plus 4? Oh, I didn't specify. Did I not do the thing? Default system. Did I restart or what? What did I do? Okay. Huh. Well, I did the right thing. It's just doing the wrong thing. Did I specify that? Wait. It's actually really. I've just deleted the target directory. I'm very confused. Did it have some old class loaded? You don't want to have that. Well, whatever. The point is, you can ask it questions, about dogs, right? So, do you have any neurotic dogs? Okay. There you go. So there. I'm sorry, but I don't have any information about specific dogs available at Pooch Palace. So it knows that what the game is. It knows that we're trying to help people adopt dogs from our fictitious dog adoption agency. So let's now help it with that process. Right now, it doesn't have access to the data that is in that database. So in order for that to work, we need to give it access to the data. And that process of taking data and using it to inform the response from an AI model is called RAG. And so in order to support that, I'm going to bring in a dependency here, advisors vector store. Okay, I think it's vector store. And we'll say org.springframework.ai. So this is a manual dependency here. Okay. Spring AI advisors. Vector store, I guess. Let's try that. Oop, store. Spring. That's the issue. Surely. There it is. Okay, so we've got the actual dependency. And that's going to allow me to then, within an interceptor, give it access to the data in our database. But I don't want to give it access to all the data in the database, just the data that might be germane to the topic at hand, which is our dogs. So let's go ahead and copy that repository, that the infrastructure from the existing code to read the data from the SQL database. But we don't want to give it all the data, right? Like I said, where's my here? This is the event dog dog adoption. Where's my controller? Controller, please. There we go. Scroll down. Where's the dog? There you go. Dog repository, dog ID. Paste this all over here. Okay. And here I'm going to be using Spring Data JDBC to talk to the database just as before. So Spring boot starter data JDBC. Okay. Spring Command Shift I. Go over here and reload this. Good. Okay. So now that we got that, we want to take all the data from the SQL database and then write it out to a vector store. A vector store is a thing that's optimized for semantic similarity search. Okay. And so I happen to have all the data in the Spring Data repository there. So I'm going to say for each dog, let's create a Spring AI document. Okay. So a document is just that. It's a bit of data that contains germane information about what we're trying to do here. And it's arbitrary. There's no schema per se, as long as it's the same style for every entry, right? So I'll say dog.id, dog.id, dog.name, and dog.description. And then we're going to write that out to the vector store like this. So, oops, did I inject the vector store? Oh, I did. It's right here. Vector store, vector store. Oh, there's two of them. It's called store. So store.add list.of document, okay? And get rid of that. Now, this is a document about dogs, so I shall call it a document, okay? There you go. Now, we have to tell the model to then consult the vector store for that. So we'll give it a question answer advisor, which is why I had all those gymnastics trying to get that dependency on the class path. Is I need this question answer advisor to be present. I'll import that, reload. Okay, so now it's going to initialize the vector store for the first time. It's going to fail because it can't find the table into which it's to initialize the schema. So I'll restart that. And if you go over here, and the same as before, go to our property file, you can see we've got this data source. Hit test connection, hit apply, hit OK. Go here, refresh, my database, public, tables, dog, vector store, right? And so it's actually calling OpenAI. It's getting the embeddings for the data, running it out to our vector store. Now we can go here, HTTP, do you have any Nordic dogs? Okay, and look at that. We found our boy Prancer. Okay, great. This has worked or failed or whatever. I don't know what the result of this is. We have Prancer, but before we continue, let's make sure to disable that code. I don't want to reinitialize the vector store each time. It's both costly and time-consuming, right? So there we go. If false, do that. Now we've got our dog Prancer. What's the natural next step here? I think the natural next step would be I want to adopt this dog. So I'm going to go ahead and I'm going to create a little service here to schedule an appointment to dog adoption scheduler to come get the dog from the shelter. Okay. So schedule adoption. Okay. For dog ID and string dog name. Okay. And I'm going to make this a tool. So we want to give access. We want to give our model access to our AI, to our business logic. So we can say schedule an appointment to pick up or adopt a dog from a Pooch Palace location, right? So that's just the tool. We're giving it a description here because the model is going to actually sort of intuit based on these descriptions whether it should invoke this thing or not. So we have to give it very, very clear details here, right? The ID of the dog, and tool param. So when your mom told you to use your words, this is what she meant, okay? Name of the dog. Here we go. And I'm going to just return a time in the future that is 3 days later so that we can be assured that it's not just plucking a random value out of its AI. Okay, system out, scheduling, pickup for dog, okay, at, and then here, var I, and then return I, and then here, at I, okay? So we'll see if it invokes that. And we need to give it this tool, this arrow in its quiver, by injecting it as a tool when we make that call. And we're just going to specify it as a default tool, like that. So I'll say default scheduler, and then down here, when I make the request, I'll say default tools, scheduler, okay? Let's go ahead and restart this. Okay, and now we try again. Do you have any neurotic dogs? Okay, good. Prancer. Now, fantastic. Fantastic. When can I schedule an appointment to pick up or adopt Prancer from the London location? I need that elevator music. Okay. So London on May 12th, today, May 9th, right? So that's 3 days hence. And yeah, scheduling that. So that got invoked. That's good. But still, this is all in my local Java code. All these days, there's this new protocol called MCP, Model Context Protocol. Who's heard about this? Fantastic protocol. And we, the Spring team, the Spring AI team, we built an SDK for Model Context Protocol within the first few weeks of its announcement back in November. It's so quickly, in fact, that Java implementation is the core Java SDK for the official Model Context Protocol.io project now, okay? And so we then rebased our support based on top of that. So I'm going to go back to the lab again, and I'm going to build an MCP service instead of having that local tool. This should be fairly simple. We'll call this scheduler. Hit enter. We're going to open this up, CD downloads, UAO scheduler, okay? And scheduler is just going to be the code that I just showed you. I'm just going to take that very patent pending, very hard fought and hard won scheduling logic that we wrote there. I'll paste that here, okay? And I'm going to tell Spring MCP's support to export that functionality, like so. Method tool callback tool objects, okay? And dog adoption scheduler. And scheduler, and build, okay? There's this. So that's all I'm doing. I'm just going to put that there, and I'm going to open, I'm going to run this in port 8082, okay? So now we go back to the actual assistant, which now has a dog scheduler-shaped hole in the compile unit, right? And we're going to point it to, instead, our MCP service running on port 8082. So we're going to say MCP client. Oh, we have to make sure we have the right pom.xml. I do have the right one, right? I did change the POM. Yeah, okay. So MCP client, return MCP client. Sometimes IntelliJ gets weird with types. Okay, does it not have this? Oh, do I have, did I not add the MCP client support? Here, let's go back and do that as well. So MCP client, that'll be the first problem, okay? So copy and paste that. Put that there, reload, MCP client. There we go, .sync. And we'll say HTTP, new HTTP client, HTTP localhost 8082, okay? .build, that's the hard part we did, right? MCP sync client. Okay, good. We'll say mcp.initialize, and then return MCP, okay? That's it. Now we need to inject that and put it as a tool there. So put that there, return that, and when we configure this, we'll say default callback, tool callbacks, new MCP sync, new sync MCP, whatever. I got the code over here. Let's just take that note, default this one. They changed this just recently, that's why I forgot. Okay. Oops, I deleted something. There you go. And then there's that. Reload. And 21 seconds to spare. Let's see if this works. Okay, hold on. Wait for it. Here we go. 1, 2, 3. So, do you have any neurotic dogs? Yes. When can I schedule an appointment? 10 seconds. May 12th. Okay, so here's our assistant. Here's the scheduler being communicated with via MCP. My friends, we have, in just a span of 50 short minutes, built a dog adoption service. We built it modularly in a well-structured fashion. We use Spring's modular support, Spring Data JDBC, Spring MVC. We use virtual threads. We use observability. We use GraalVM to build native images. Then we built an AI assistant that has a conversational awareness, and we supported things like RAG and tool calling. Then we use the brand new Model Context Protocol, of which, by the way, there are thousands, right? There are thousands of different MCP services, and now they're all available to you in your chat client applications. Notice that this was a protocol defined by Anthropic, makers of Cloud Desktop, and yet I'm not using Cloud Desktop here, right? It's a protocol. Anybody can use it, and that's the beauty of this, is you can consume MCP from any of your services and add this behavior to your code. There's some really wild MCP services out there already, and you can get started and join the fray today. Thanks, my friends, for hanging out. I have a question. Who learned something? Who learned something new? Who had fun? Okay, you're awesome. Thank you for coming. Have a great, great time.